am wonderful. Uh, Yes, so welcome to the July Town Hall. I couldn't be more excited to have everyone here today. I'm very excited about our topic and can't wait to get to our speakers. But we'll kind of go through a couple of these early slides just to get us started today. So if you have any comments or questions during the presentation, please make sure you can just put those right in the chat function, and I will ask our speakers those questions towards the end of the presentation. If you do have any other comments or feedback or anything you need from IGSBA, please feel free to send us an email at info@igsba.org. If we don't get to your message or your question in the chat function, we will send it along to the presenters and then send you an email with the answer later. So I am Courtney Lull. I'm chairperson of the IGSBA Board of Directors. And I'm so grateful and excited for the participation we've been having in these town halls. It's just great. So as a reminder, membership renewals, there were a lot of people that do expire on, or did expire on June 30th. If you have any questions about your renewal or the renewal process, again, feel free to send an email to info@igsba.org and we'll be happy to help you any way we can. So hopefully everyone on this call got the new information that went out yesterday that IGSBA is going to have a conference. We've been graciously invited to participate with National Groundwater in their Groundwater Week, and we are so excited to just get together. Excited to meet in person and be able to see all of these wonderful faces, some new to me, some not. I can't wait to just get together. We'll have some great topics. We're going to work on speaking presentations. So if anyone on the call has a speaking engagement or a topic that they would like to see discussed, again, feel free to send an email to info@igsba.org and we'll be happy to put that on the list for consideration. But just honestly very excited at this opportunity. It's been a while since IGSBA's had a conference and I can't wait to get the band back together, so to speak. So without further ado, I cannot wait to hear from Zainab from HEAT and Nikki from Eversource, and they are going to talk to us about an amazing project going on in Massachusetts and how it started, how HEAT started, how Eversource got involved, and then what the decision-making process was to look at a district geothermal system that is owned by a utility. I think this is just a great topic. I can't wait to hear more information and then be able to share this with utilities across the country so that we can start to see more of these. So if you guys would like to get started, go ahead.
All right, I think unmuting is a good start.
Perfect.
Here we go. And is that, everyone can see that well enough? Excellent. So I'm really delighted to be here to share our story today as well. And I want to start just by stating that I'm a co-executive director at HEAT, and the story and the work that I'm going to share represents the work of many, many people, allies, the other co-executive director, Audrey Schulman, who will be joining us for questions and answers, and also Eversource, who is here with us to share the story together. So we're going to be kind of passing the baton back and forth. And to start, HEAT is a nonprofit. We are committed to socio-technical systems change to solve for climate. We take no money from gas or from geothermal, and appreciate all of the foundations that allow us that independence. So thank you. And I'm going to pass it to Nikki.
Hi, thanks, Zainab, and good morning, everybody. Thanks to Courtney and IGSBA for having us. My name is Nikki Bruno. I'm the Director of Clean Technologies at Eversource, which is a newer role for them. And I just wanted to spend a minute talking about Eversource for those who aren't familiar, but we're actually a triple utility. We have gas, electric, and water. We're the largest energy company in New England with over 3 million customers and over 9,000 employees. We recently acquired a gas company in Massachusetts. So increasing our size. But with that, if you're following any of the legislation or the climate crisis, as I'll call it, New England has been very progressive about emissions reductions and kind of the energy transition in general. And so, being in that space, we actually have our own 2030 carbon neutrality goal for operations, which we been leading some of our peers in and we're excited about, but, it's kind of expected. In the region we live in, we have to innovate and get creative. And I know what folks may be thinking. They're thinking utilities may not necessarily always be the place for that, but I'm going to be the optimist today on the call and say that it's a really exciting time for utilities, especially gas utilities, because we're on the precipice of change. And I think you'll see throughout the presentation today that, really geothermal is an exciting opportunity and could be a great part of the solution of that energy transition. And so we're eager to test it. And, one other thing I'll highlight, which you'll see throughout, certainly while we're talking, like Zainab said, we're going to try to do something a little different today, just to highlight the uniqueness of the relationships we're all forging on this issue, because it's really complex. It's difficult. No one entity is going to solve climate change in and of itself. So, we need to find common ground and we need to work together and start chipping away ASAP. So I'm happy to be here and happy to answer any questions that I missed talking about on the pilot itself. But I'll pass it back to Zainab for some more of the background on the relationship.
Thanks, Nikki. And let's see if I can advance the slides. Yeah. So I've got little placeholders for the story. I will try to not get lost in the details, which are really fun. But you might be wondering, basically, really fundamentally, how did a climate nonprofit / activist organization start trying to solve problems together with a large gas utility company? So I'm going to take just 5 slides to describe how this came to be. And I believe the power of it, of working together across what are typically seen as divides. So it didn't start in the most together of ways. This is a map of all the gas leaks in Massachusetts. I very tactfully have put up a map of Eversource's competitor, National Grid. These are not Eversource's leaks. And HEAT was the first to provide searchable maps of gas leaks back in 2015, which launched a movement in Massachusetts. It started with tagging the gas leaks, putting signs on each leak in town to raise awareness of the problems both of waste and of climate, because methane is 84 times carbon dioxide in the first 20 years. So it's a kind of a superpower, super emitting greenhouse gas. And that built a large amount of interest. It turns out no one likes gas leaks, pretty much no one. And when a scientific research paper was published in early 2016, we were able to take that movement, that power, that interest, and turn that science into policy, passing a law less than 6 months later requiring the prioritization of large volume leaks in order to cut the methane emissions from the gas system's old pipes in half. And we thought we'd done it. We were done, and we hadn't yet met Eversource or National Grid or any of the other gas utilities. And then we discovered that there wasn't a known way to do this actually on the ground. And so we cared about it being real and reached out to each of the gas utilities to talk to them. And just to be clear, this is a photo for something that might have happened along the way. It's a trending Twitter storm of mothers, and there's some large gas leak orange suits. So again, this was reaching across a big divide. And I want to make that clear. But that first meeting with Eversource President Bill Akeley, we sat down and we said, well, look, we're concerned about our kids' future, which is a very strange way to start a meeting. And the pivoting moment was he looked back at us and said, look, I've got 3 kids and I'm concerned about their future too. What can we do? And pretty much everything starts from there. So we engaged each of the gas utilities in a study of how the technology, how to find the largest gas leaks. We invented a new one and went out in the field for a summer, got the data, got the research, the science, showed which way was the most efficient and most effective, and then brought everybody together in a large 300-person summit at MIT. And it was a great success. We collectively agreed on a shared action plan between the utilities and HEAT and all of the allies. It was also a great success because there were absolutely no fistfights, despite the very, very vast range of opinions in the room. It was inspiring. No one really thought that could happen. And so having accomplished that, and there we go. And we jointly presented to our public utility our shared action plan. It's enacted into regulation, and we are now in Massachusetts well on our way to cutting the emissions significantly from the gas leaks in our aging pipes. So, wow, can we use that method of connecting across divides to solve something even harder to solve, even bigger? And in 2018, that's what we set out to do. We had learned enough about the gas system and its aging pipes. It was very cutting edge in the 1800s, and kind of impressive that some of those pipes still work, but still leaking. And we have climate mandates now that require us to decarbonize. So what is the future of heat? And what we concluded, and I never speak for anyone else, but for HEAT and myself, is that business as usual is not an option. That the aging, leaking infrastructure needs investment in Massachusetts, billions of dollars, that the gas system cannot get us to our climate goals. So investment is a challenging decision. And also that some of the other options could significantly raise the cost of heating. At the same time, we understood on the ground that allowing collapse, allowing there to be no plan, is not an option either. Our current status quo, we don't have a plan. And so as we electrify, millions rely on this gas system for affordable heat, and the gas system costs will rise. And as they're increasingly borne by vulnerable populations, this is a huge equity problem and a hazard, and no one wants to see that happen. So we need a plan. And in Massachusetts, as in many, many aging cities, there is an effort to replace some of those older pipes. In Boston, over 40% of the pipes are scheduled for replacement, and the collective cost, including cost of capital, for this statewide project is somewhere between 12 and 20 billion. And that's a lot of money to be paid back over many, many decades. So is it what we want to put in the ground? Or could it lead to risks of stranded assets? To me, there's a pivot point right now. And that pivot point could be seen as an impending hazard or disaster, or it could be seen as an enormous opportunity. Can each of these sites be the seed or the nucleus of renewable energy, of a new system that meets the needs of the future? And I think that's what we were trying to figure out. So we didn't do it in the most, oops, there we go, graceful ways, but we started talking to, HEAT started talking to everybody, as always. One scientist said, well, you know, the gas system is like a tree, and if you are going to prune it, you have to take off the outside branches. And we took that image and presented it to the gas company utility presidents and talked about this challenge we saw. And they were so gracious to not be horrified by our image, and to instead have a real conversation about these challenges. And that real conversation, together with many others across a wide spectrum of people, led to a set of design principles which we saw as necessary to achieve for all of the stakeholders to have their needs met, to wish to move forward, like that sweet spot, that common ground across the system. And it's quite a list, and we got a lot of laughs. So I'm going to try to speed up, I'm sorry. So the geo microdistrict idea emerged out of that. And I really want you to have that background, that we were looking for anything that could meet these needs. And you all know that ground source heat pumps are absolutely one of the most efficient decarbonization paths we have available to us. And also that if we decarbonize heat one house at a time or one building at a time at the rate we're going now, we're not even close. We have to accelerate massively. And not every house has the means or the financing to make a transition to a ground source heat pump and or the land availability, especially in more dense regions. And of course, a gas utility is not an individual ground source heat pump installer. That's all of you. And so, but a gas company could provide district heat in denser areas of some kind, potentially. And so we kind of put a hybrid together. And let's see, this is, we do not have a graphics designer. I'm just disclaimers. This was the first drawing of the idea I came up with, that why couldn't we connect or network ground source heat pumps together, put the borehole array in the street, use the right of way of the gas company to provide that available space, and use the gas company as a thermal management utility to deliver thermal energy instead of gas to each home. And each home could have a heat pump to pull the heating and cooling they need off. And you can see there's centralized pumping in there. And I want us to pause for 1 second and acknowledge that I was clearly not the first person to come up with this. I was absolutely delighted to discover that, in fact, folks like the Gray Edge Group and Carrie Smith had put one of these very similar design, much more complicated actually, into the ground out in Colorado Mesa, and had been running for 10 years and doing great. That was a wonderful gift. And I love convergent evolution. There's a lot of people out there working on how to put our known components together in innovative ways. And I just really appreciate all of you. Thank you. And so we talked to the gas utilities and said, well, what would convince you to pilot pulling out one of your old leak-prone pipes and putting in something like this and just trying it? And they said, well, we really need numbers on feasibility, both technical and economic. And so we launched an RFP for a statewide study of the feasibility of the geomicro district. And that was in 2018. And thankfully they had graphics designers. So this is a more accurate artistic representation of the idea. Bureau Happold Engineering did a really great job with a challenging problem. And the piece that I want to mention as I briefly explain the feasibility study is that interconnection isn't an interconnected set of ground source heat pumps, doesn't have the same properties as, of course, an individual install of a ground source heat pump. A little bit like, to me, I use the analogy of a computer to an internet. There's emergent properties. So yes, there's economies of scale, but there's also wonderful load sharing or canceling, where a building using heating and a building using cooling simultaneously can cancel. And then there's the thermal storage of the borehole array, so non-simultaneous loads can cancel. And so you get these crazy increased efficiencies by networking together ground source heat pumps. And that is part of what Bureau Happold's study explored. This is a very oft-repeated slide from it. And I actually am sharing it because I wish we'd explained better in the report. This is a comparison of a very limited install between different densities. So it is not, these aren't limits. It's saying that in a set amount of street space with set spacing and set lengths of closed loop vertical boreholes, this is how much you can cover. Of course, if you were actually designing that medium density residential, you would just make the boreholes a little deeper or find some more space. So just to clarify that. And one of the pieces is that if you want to, if you have the ability to manage the thermal energy, then you can overproduce or provide excess thermal energy, still achieving balance and thereby expand the capacity of the infrastructure, maximizing efficiency. And there's so many options for thermal management. You all probably know many more than I do, but some of the fun ones are, pre-warming irrigation water or melting snow on sidewalks. But of course, you can also just fire up a boiler or condenser. And this was designed entirely as, again, a strategy for the gas infrastructure. And so it has a growth model. One geomicrodistrict is the replacement of one broken pipe. And then there is iteration. And as these installs go in, they can be interconnected. And we have a couple case studies showing that interconnection and backing the gas system up in a kind of hybrid until perhaps in the densest areas you do have a biogas or green hydrogen as a backup or a supplemental heat source. But you're growing from the bottom up. And when you're looking, and Nikki's going to get to this, I'm rushing to pass it to her, but when you're looking at different sites, this is actually maybe one of the most important slides from the feasibility study, that high density mixed use, sure, it's a higher energy load, but it's closest to balance in general. And so because it's closest to balance, you're actually getting the most energy efficiency of those kinds I mentioned out of it. And so that's actually the target of where to start. And I should probably not do this slide, but I want to specifically mention a couple design parameters that I'm trying to work on definitions, and having that shared loop of energy in the street be ambient allows what is shown here for a stable, balanced energy system where you're storing energy on an annual basis without any thermal drift throughout the system, and you can manage to maintain that. And I'm so aware of all the different designations and language choices right now. And I've been trying to collect them into one chart and sort them out. And this is my attempt. I'm not going to read this, but I think there's a huge need for standardization of language. In Europe, they came at it from district energy and jumped to the ambient loop and called it 5G. But here, that just means cell phones for a lot of us in the US. So I've been calling the large scale system a geogrid because I found it's catchy and people remember it, despite having used geomicrodistrict for the like block or unit that you interconnect. But we'll see where it lands. And I'm sure you have all run into the confusion around the word geothermal. I'm glad your name is Ground Source Heat Pump Association. And so I have this slide just to try to address this. No, I'm not drilling down into hot lava. No. And so I explained that, you know, I try to avoid the use of the word geothermal because of the confusion. So very simply for the engineers among us, the way I'm defining this geogrid idea that fits the gas company's needs for decarbonization is it's a hybrid system. It's decentralized because it's heat pumps in each building, but it's centralized because of management and optimization. It's an ambient temperature shared loop, allowing bidirectional energy flow and waste thermal recapture. And this, of course, allows heating and cooling. Cooling we need more of, and also allows us to manage and shift over time as our climate changes. Next one is, instead of adding up a sum of all of the loads of all of the buildings, and then saying we need this much infrastructure, you're designing instead for kind of a stochastic or probabilistic, if that is a word, load, because the more buildings you have, the less likely it is you're ever going to have all buildings on peak load, a little like the electric grid does. And so that really reduces your infrastructure costs without risk because you have a backup. And then finally, this opportunistic and site-dependent design process is of course necessary. I'm sure you all totally understand that. All right, I'm done with definitions, and I'm going to turn it over to Nikki because once we finished the feasibility study and had some workshops and worked on all of this together with them and many others, Eversource was the first to move.
I don't know if I can click ahead, if there's a way to easily do that.
I can,
but
if you just say next, I'll do it.
Yeah, you can go through these. So in the effort to combine and streamline, you can go through the next 2 slides, but in case anybody wants to know about carbon neutrality at Eversource. But the next slide, please. So like Zainab said, I mean, I think I think you can, she laid, there's so many puns here, I'll try to be good. So much groundwork for, a lot of the complexity around installing the system and kind of what you need to consider from both a technical and a stakeholder. So I'll try to marry that all up here. But what initially had come out of a lot of those discussions that Zainab was referencing was a filing that we made under our gas rate case. And we brought that to our Department of Public Utilities, our regulator in Massachusetts. And in October of last year, we received approval for our geothermal pilot. It wasn't exactly what we had filed, so I'll just go through kind of some of our train of thought. We had actually proposed 3 different geothermal pilots, network geothermal, we were calling it. One was a multifamily building unit. One was a dense urban area with mixed use customers. And the last was a residential neighborhood. And what ended up coming back was that they had approved the mixed use dense urban proposal. And some of the rationale that our DPU had said to us was, well, geez, you could probably include a multifamily building in that area of your gas service territory. And the residential neighborhood, had kind of been done in some form or fashion. And also we could include residential customers in ours. So the exciting part though, was that this was the largest proposal we had put forth. And so, it's just over $10 million worth of work. It's a 300-ton system, give or take. And, I don't like to anchor folks on how many customers or units that equals out to, but just by way of, setting that up, if it's a 3-ton install per unit, 100 customers. And so we're really excited, but as you'll see from me throughout the presentation, we're students of geothermal. We don't have expertise in-house. So, this really was a leap for us. And I think, the collaboration and kind of relationship with HEAT and others as we went through, the filing actually started in our energy efficiency department. We have emerging technology groups there who will investigate, try out new ideas. But, when they started investigating, it was, geez, this might fit for gas and for so many reasons. So I'll get into that in a second, but next slide, please. So, I think just taking a moment to pause here, I already told you this was the approved scenario, but, what was really neat for us, at least, is that, the department said it was consistent with the Global Warming Solution Act and the 2050 goals for climate, for emissions reductions and climate change mitigation. So, I mean, that's really neat because sometimes, these filings are pretty bland, cut and dry. And so, for them to go out and just say something like that was really important to us. And they thought that this could really inform decisions coming forward. And so what's happened, and we can have a separate conversation or happy to take questions offline about this, but since the geothermal pilot had been approved, Massachusetts is actually undergoing a proceeding with all of its natural gas local distribution companies to see what is the energy transition going to look like, what is the future of those companies, of our companies by 2050. And so, the network geothermal option becomes a very real solution here. So we were very happy to be already out of the gate and looking to test. Next slide, please. So in addition to some of the questions on the screen, I just wanted to kind of ground folks in what are we really looking to do here? Because the technology is proven, right? A lot of folks on the phone know that in and out, day in, day out. But, from a utility perspective, we're really interested in how does this work at scale? We thought it would be really great to leverage our capital investment ability, our ability to utilize long-lived assets in the ground and install them, monitor them, operate and maintain them. So, out of that, the first question is, could this be a viable, fiscally viable business line, a service we could offer our customers? A second really big picture item for us was, what's the environmental value that this brings? In our filing, we had actually proposed that this pilot would convert heating fuel customers, so oil, propane, delivered fuel customers. And we did that for 2 reasons. One, because, when you're trying to market something to a customer or trying to get them to participate, you have to approach from all different types of angles. Some things move some folks and not others. So, but to convert from delivered fuels to something like geothermal heating and cooling is really important because it has both environmental value with decreased emissions and cost savings. So what the department told us in the order was, geez, it would be really great if you could also convert some existing natural gas customers. So what that's morphed into is, can we get a mix of gas and delivered fuel customers in our pilot? And, you know, to answer that second question, we'll have a good sample set of what's the environmental value that this brings. And the third, and probably the most, in my mind, the most interesting is, how does this serve the customer? Does it meet their needs on the hottest and coolest days of the year? You know, does it match their expectations? And so, you know, we're also looking to kind of, I'd call it a more subjective. We're trying to make it as objective as possible using things like degree days and kind of how the system functions physically. But, you know, we really need to understand how the customer adoption goes. And so in addition to, is this the right business model? How well does the system actually perform? And other cool hypotheses like Zainab had already kind of alluded to, which is, you know, with the shared loop, can we gain efficiencies? Can we reduce and shave that peak load because you have that mixed use? We're really excited to test all that, but you know, the customer piece is critical here. And I think, you know, at least on me, you know, it's incumbent that we don't, we take very seriously how we're conveying to the customer information about environmental value, costs, installation, and these are some data points we want to look at while we're going through the process, but the customer acceptance of the technology is critical. So I won't go through all of this because I kind of hit on some of this, but along with the technical performance and actual, you know, operating costs and installation costs and all that, and customer, we're looking at carbon reduction measurement and ultimate cost savings to the customer's bill in both heating and cooling. And, you know, in New England, some folks don't have air conditioning. So it's been really interesting, really neat to see their reaction, like, oh, this will provide cooling as much as heating. So this pilot is designed to only address space conditioning, but you know, some interesting facts about it. I mean, that is the biggest piece of the load. So, you know, we're not at this stage, you know, changing out stoves or maybe dryers, but the space conditioning is not insignificant. And what's really unique is the DPU allowed us to cover the cost for the customer of the actual ground source heat pump installation, which traditionally there's a demarcation, an invisible demarcation line that we usually do not cross as the utility. So, you know, this pilot overall, we're going to be answering key technical, fiscal questions, but also customer questions here as to whether this becomes a larger offering. Next slide, please. Mm-hmm. And so, you know, I think, you know, for the purposes of today, this is a little bit of, well, why is the gas company looking at this? And we talked about some of this, so I'll move through. But, you know, I think, and I want to comment on the vendor ecosystem, or kind of the geothermal family, I'll call it. I understand, you know, some folks view the utility as, you know, a corporation, not necessarily a community partner, you know, or maybe a small business or anything like that. But I think what we're trying to do through the pilot is, we've told the department, we are not the experts here. And so we're running I just finished one, but we're running active procurement processes to bring on third-party help, whether it's a design consultant or a driller, an installer, and even an evaluation firm to monitor how everything is going. We're eager to work with folks who have the expertise and to build those relationships similar to what we have today with the gas system and the skilled workforce and the consultants and third-party teams that work with us every day. We understand that this can't be done by the utility alone. And even to gain in-house expertise on it, so to speak, is going to take a while. So we're really excited to kind of try that out. And it's been interesting, you know, learning. Folks seem to do quite a bit. It's not just, you know, one person doing the ground source heat pump installation. They're used to doing much more than that. And so leveraging the existing skill sets and using kind of our skills underground with the gas side of the business, we're looking forward to kind of, especially that design and installation. There's a lot of similarities there. You know, and as the utility, what I will say is, you know, in terms of some challenges and opportunities, as we've been going along here, you know, we're heavily regulated. So ultimately, as we're going through this pilot, I'm thinking, well, what does the regulatory model look like? So we could make this an offering, but we're used to setting those type of things up. I won't bore you to death with regulatory pieces per se, but you know, out of this pilot could come a very real framework that ties in not only to, you know, customer offerings, but also to the overall plan for the gas companies to transition to meet our goals in the state of Massachusetts. And, the way New England area looks, if this works in Massachusetts, there are similar proceedings and targets and or working groups in other states that we operate in, like Connecticut. I know New York just made some great announcements in the city about network geothermal. So, there's a lot of great, to Courtney's first comment, population of ideas, and hopefully this takes off. I've talked to a lot of different utilities about this. They're eager to learn how we're doing and kind of what they can do in their own territories. So next slide, please. So I kind of went over a lot of the benefits as I was going, but so maybe I'll use this opportunity here just before I hand it back to Zainab, just to say, we had an initial schedule and we were ideally selecting a site for the pilot to be located in by this spring. With COVID and just the complexities as we learn, we've never done this before, as we're learning as we're going, we've had to delay that. So I'm anticipating that we'll actually have a site or, a top site or two selected by the fall. And then we'll begin acquiring our customers to participate in the demonstration. And if for folks who are interested, I'm happy to email Courtney or whoever on the side, but we certainly have a docket open in Massachusetts. We have an implementation plan just chronicling what we've done to date in front of our GPU, if anybody's interested. But we'll be providing periodic updates there. And, Zainab and the HEAT team have been wonderful with holding monthly charrettes during COVID, which is no small feat, as I'm sure they'll tell you, where we've been trying to share our updates and information and insight, but truly gaining quite a bit more by participating in these discussions where you have diversity of thought from a lot of different stakeholders on, their experience with geothermal, what matters to their community, if they're community leaders or activists, and, how we should go about installing this, because we do have a blank page here. And I think that's really important because wherever we end up citing this pilot, it's going to be the community that we're working literally in day in, day out, opening their road to install the shared loop, connecting their customers. And, there's some aggravation there, all for a good end product, we'd say. But they really need to be an open partner, a willing partner. And luckily, I think in Massachusetts, a lot of the local municipalities have their own carbon goals. So we're excited about that. And then, like I said, the charrettes have offered an opportunity to work together on some common ground issues around geothermal, where maybe traditionally, to go back to the top of Zainab's presentation, you wouldn't necessarily find a gas utility employee sitting next to somebody from maybe an NGO or community and happily laughing and working through challenges. So eternally grateful for that opportunity, and I think it's made a better product, but it's been a complex journey. The site selection is really important, and we're willing to take the time we need because we want to get it right, because we understand how pivotal this pilot is and how it will inform others. And I think with that, that's probably a good segue to hand it back to Zainab to bring the presentation home.
Well, it's a beautiful statement, and I was thinking as you were saying that's part of what socio-technical systems change is, that to transform our energy system, we need to not just connect heat pumps, but also connect people. And you can't do one without the other. So as Nikki already mentioned, I think she's mentioned a couple of these things. There's a lot of movement right now. I'm sure some of you have heard about some of this, and there's a pipeline of other projects in consideration coming along. The moment seems to be now, both because of the pressure of decarbonization plans like the one Nikki mentioned in Massachusetts, and then there's one in California and Colorado, et cetera, New York, and also that aging infrastructure and in many places, and that accelerates the pressure, and then of course climate change itself. So there we go. Nikki also mentioned regulatory and legislative changes needed. We are trying at HEAT and in the Gas Leaks Allies, a larger group of a larger alliance that we work closely with, to predict and preempt move barriers ahead of the system. And we have a filed legislation that addresses each of the points that we see as potentially needed, including permissioning, really changing the definition of a gas company to utility scale thermal delivery, and very carefully, by the way, and also limiting gas pipe depreciation past 2050 to match our climate plans. So both directions of things, and a securitization plan that addresses the worker retraining and low-income retrofits that would be needed regardless of which electrification path is chosen. And so Nikki had a list of benefits, and they're the same. There's energy bill projections. I'm sure you all understand that it's cheaper in the long run. And I'll just mention that the workforce in the gas companies is already working with HDPE pipe, and that some of the case studies, like the fabulous one at Colorado Mesa University, are giving us really hopeful data about the potential of a scaled system to flatten electric peaks, allow load shifting through thermal management over space and time, and provide storage at a lower cost for the electric grid through thermal energy. But maybe most obviously, this process gives equitable access. So those who are not able to have the means and motivation to transition individually can move to clean, green energy now. So we are running monthly charrettes. You're all invited. And we also have an open library of resources and tools we're building. We believe that what is needed most right now is a standardized data set collected and centralized for comparison between all the installations going in, standardized evaluation, so we can really learn the most out of all of them. And we've been doing things like building a cost change model and other activities to try to move towards that, and we could use all the help we can get. And basically, together, we do have a chance to transform our energy system. The gas utilities have the size, the financing, the power, the customer base, and potentially the motivation to drive this form of electrification if the data shows it's viable. And that is just utterly enormous. And we can do it if every one of us works together to solve and remove barriers and move forward. And just to present what I think will happen, this is the gas grid. Some of it was put in the 1800s. It's actually quite beautiful and impressive, and we get to reimagine it now. I want to acknowledge that some of it should be strategically abandoned and individual heat pumps installed, and that is necessary in some places. I also want to acknowledge that some of it should be strategically maintained, that there are industries that need combustion, and that really we're looking at that middle piece, and determining those thresholds is of high priority, of which parts have the right density, the right energy use, the right location to strategically evolve. And that's it. All of our materials at HEAT are put under Creative Commons, so they're open. It's like an open source system. And we ask you to take anything and only ask that if you improve it, to please share it back. Thank you.
Thank you both. Very excited. We have some great comments and questions. So we'll start with Tom asked a question. And I assume this might be a little bit early, but what discussions have taken place on service down the road? In particular, air introduction into the loop or pressure loss from service or accidents in a home or business?
Yeah, so Tom, I'll take that one. I mean, we are just getting into kind of some of the more detailed questions, so I probably would be better suited to answer that later, but it was so funny. We were literally just talking about air introduction, how we're gonna set up, thinking about the design. I think generally, what I failed to mention was that the pilot is a 3-year term. So, right now we're waiting for final approval from our DPU for the customer agreement. And what we tried to do in that is allow the customer to have enough ability to understand that wherever we land in 3 years, that they won't be holding any sort of bag, that they can freely participate in our incentive or, encouraged to. So, we're hoping that by being the utility, we understand the meaning of reliability and resiliency, and we have to design our traditional systems with certain factors in mind so that they will have no fear of that. And then, if there was some reason that the system did not work, that they would be able to have some comparable system returned to them if they wanted to for whatever reason. But those type of discussions around the air introduction, those are things that are going to be happening soon, and as we get into more of the site specific details as well.
I'll just add with my voice that the gas system itself is vulnerable to single point failures. If you have a third party hit, anything downstream is cut off, and it is explosive in a certain range. So the shift to maintaining pipes that have water in them that also have less vulnerability to single point failure is really a shift towards a more reliable system.
Excellent. So Matt asked, how will the shared loop work in places with delivered propane that are more rural in nature?
Yeah, so for this pilot, Matt, we will be only looking at an urban area. But we do expect that there could be some propane, that certainly would qualify under delivered fuels. But I don't know that. I don't know how prominent it will be. A lot of towns and cities where our gas service territory overlaps has a high gas penetration. So, but propane is still used. And I think heating oil is at close to 30% in Massachusetts overall. So there's still, I don't like to use the phrase low hanging fruit ever, but there's still some not as clean fuels that could benefit from the conversion to geothermal. But in rural, more rural areas, I would imagine without the expertise that it would just take a different type of design. And, I don't know what you would sacrifice with efficiencies on a shared loop if you were converting.
I would separate. So if you have a denser area in a more rural setting, and because of gas capacity constraints or the cost of the pipeline to bring gas to that rural location, this is a great opportunity as long as you have the density to justify interconnecting. There's a threshold that we don't know yet, at least I don't know yet. If any of you do, let me know, where it is no longer cost effective to interconnect the dense energy load density in the distance available. So that's one thing we need to learn. I would assume that the majority of rural buildings and households would require single building heat pump solutions.
And I will say, Matt, if you hadn't had an opportunity to participate in the Boyd Lee presentation, there is a co-op in Oklahoma that has done just that, where they own individual loop fields for individual customers based on it being a bit more rural. So that may be a good listen for you. So Kevin mentioned that water source refrigeration and freezing is very efficient and the equipment does last longer. So I realize that this pilot you can't solve all of the problems at once, but it does seem like that there is a tremendous amount of opportunity for water source refrigeration as well as domestic hot water down the line. But it sounds like a really great start.
And actually there's some of the pilots being proposed next include more.
Wonderful.
Yeah, there's a lot of opportunity.
It really is a bit limitless, to be honest. Kevin asked, it was mentioned that the initial pilots were developed in the energy efficiency program. Was fuel switching a regulatory hurdle that needed to be addressed?
Yep. And so, Kevin, I'll clarify too. They were developed by folks who handle a lot of our emerging technology. So not necessarily through our what we call our Mass Save program, our energy efficiency program itself. But, on the fuel switching point, I think what we had proposed was converting delivered fuels initially. And so I think, the intonation to the DPU was, look, these folks have high cost and high emissions. So, we could convert them to geothermal for this pilot and reduce both. That would be the hypothesis. Of course, we'd have to test. But in terms of I don't think they had any issue with that at all from a regulatory perspective. Where the natural gas conversion came in, I think our regulator, much like us and a lot of the folks who are involved in the energy transition, is understanding how best to do that transition and wanted to include natural gas customers if we could do this operationally and safely, because they also want to understand that relationship. And all these different entities working together have different I'll say goals that they need to achieve, or maybe in some cases statutory mandates, like the DPU has to evaluate costs and things like that. But I mean that I think is part of it. They want to also use this as an educational tool to understand what the technology can do. So I don't believe it was much of a hurdle at all.
Yeah, there is a lot of support across the different state agencies for exploring this, and they're all engaged in the process for years now with workshops and charrettes. And There's currently a rate case at RDPU for National Grid's proposed pilots. And I totally recommend checking out the testimony filed this month if you're interested in this.
I think that would be huge if we can share that with the group. I particularly know Kevin. He's based here in my home state with one of the utilities, or works with one of our big utilities. So I'm very excited that he was able to attend and has some great questions. But we do find that fuel switching is a big hurdle in multiple states across the country. So being able to find a way to navigate those waters and not run up against that, and how to communicate that with regulators would be great. So Tom asked another question. Did the utility have any hurdles on the labor side of things, retraining costs, or pushback from respective organizations on phasing from gas to renewable technologies?
Yeah, so that's, that's one of those complicated topics, certainly, that we're working through. For this pilot, what we want to do is understand how this all works. I mean, I think there will be some place for, by way of example, existing labor or unions that we already work with for jobs they already do, like marking out lines or something like that. But, we don't even know yet what those jobs really look like. And so what we want to do is obviously maintain those relationships and continue to work through them and strengthen them as we go. But we're really using this as an educational tool right now, because, we certainly also don't want to make commitments that we don't have in hand yet to offer and spoil anything there. But yes, it's definitely a big issue. Actually, Zainab and Audrey hosted a charrette recently on this topic, just generally speaking, what is our workforce going to look like in 2050? So it's certainly top of mind, and we are mindful that this could be impactful on that.
And this is part of the role of having a group like HEAT trying to lead the coalition, is that, Eversource Gas doesn't have the answers yet to have any kind of specific engagement or negotiation with labor, but we can just spend time explaining what it is, what the technology is. We can build relationships and include concerns and voices right from the beginning. And we try to, it's often a very delicate tightrope to walk, but I think it's incredibly worth it to have every voice affected, every stakeholder in the room talking through the whole process.
Education is a huge thing. I mean, and it even starts down to something as simple as who's going to actually install it, and educating people as that it's not as complicated as they seem to maybe think it is, and just kind of taking it right down to the basics. So I think that's great.
I recently gave a talk in Philadelphia for the Philadelphia Gas Works project, and did it together with a steelworkers leader who we spoke jointly. He added a disclaimer at the front about being absolutely in support of gas, and then proceeded to share his enthusiasm for building this network of the future and how his guys could do it. And I think we have to kind of accept both things always.
Sure. So Matthew asked, as this is a huge electrification effort, what role is the electric side of the business playing in this pilot? How involved are they? I assume this is a question probably for Nikki.
Yeah, no, great point. And I love it's funny how network geothermal fits under the definition of electrification in a lot of folks' minds. And that goes to just kind of our point. We're trying to be overall at Eversource technology agnostic, and how do we get to carbon reductions and emissions reductions overall. So our electric side is involved. I'll be working with our energy efficiency and our electric side, certainly if it's also within our electric service territory, which in some but not all cases overlaps where our gas service territory is. So theoretically, we could have a customer who has both Eversource gas and electric. And if that's the case, it's a little bit easier, I think, just being under one umbrella, from a data perspective and sharing business intelligence around some of the customer information we might already have, understanding the load usage, or the energy usage. But certainly from an energy efficiency side, we're going to be working with whoever the customers are to offer any and all rebates we can. We obviously want to make sure that the home or business is airtight when we install the network geothermal technology. So they'll be involved from that perspective as well. And I keep telling the folks who actually prepared the filing, who are technically more closer to the electric side, that I'm not letting them go for historical benefit.
John asked, what considerations do you have around peak load reduction if you're not designing to the peak loads?
Yeah, so I need to clarify. You have absolutely designed to be able to meet peak loads. It's the sizing of the ground heat exchanger that isn't sized for an aggregated sum of all the loads, but for the to be optimized around the balance load. And in the rare event where you're shifting to the peak, you can design to have backup if it is not sufficiently covered. So thermal backup could come in many different ways. Eversource was looking at electric, but by centralizing supplemental thermal and optimizing around the dominant number of hours in the year, you cut your costs a lot. That's all I was trying to communicate. Sorry.
Sure. So Jacob asked a great question. Do you help utilities transition? How do I get our local utilities to do this? We have started engaging, but is this something you can help with? They're based in Canada.
I'm guessing that's for me.
Probably.
You know what? We certainly haven't looked at actually working in Canada, but we are attempting to build this library and share every resource and the stories of how we're doing it in order to help other people replicate whatever success we managed to have. So I'm happy to put you on our lists and share as much as we have and continue to share as we develop more.
Awesome. Should I just send you my email or something?
Absolutely. Yeah.
Okay.
I can put my email in the chat. That's kind of dangerous.
I did as well, in case anybody wants.
Great.
Thank you.
I'll just add, being Canadian, I'll put my email in the chat. You can send it to me.
Yes,
I'm from Heat also, sorry.
her inbox is much less crowded than mine. Delayed.
And honestly, Jacob, send us an email as well at info@IGSBA, and we'll be happy to point you in some right directions to some contacts in Canada that could help you. Jay made a great comment and just said thank you to Zainab and Nikki. Your contributions for geothermal uptake are profound, and I couldn't echo his sentiment more. I completely agree. Doug Doherty also added, this needs to go to every state utility regulator in the US. I also couldn't agree anymore. I think that enthusiastically, this will be available on YouTube after this presentation, and I encourage anyone on this call to send it to whomever may find it of interest, especially with your local regulators or utilities. I think this is a message that everyone will really needs to hear. Dr. Liu Xiaobing has asked, has any feasibility study been conducted before investing millions in the pilot projects?
Absolutely, and Dr. Liu, I'm delighted you're here. We did a feasibility study with Bureau Happold Engineering for the design of, the generalized design of the technology in Massachusetts streets. And then, of course, I'll turn it to Nikki for specific to the site. They have hired design consultants.
Yeah, so yeah, thank you for the question. So we're actually working with our first phase consultants, I'll call them, but we've hired a firm to help us with this. We're calling it the feasibility phase. So to vet through different sites, establish really the rigor for the site criteria, which, again, kind of harkening back to the charrette conversation we had earlier, pulled from a lot of good collaboration and considerations that we talked about at one of the heat charrettes on design and site location. So we're going to be working through that. It's kind of like a building it as you go in a way, which is super exciting because you kind of get to make up some of the rules. But there are some foundational pieces that we're obviously including as we vet through these sites, but it will just be a really good map because ideally we have gotten some good interest from different cities, and this won't be the last, so we can kind of keep logging that interest, and then we have a solid set of criteria by which to evaluate the sites to see if they're fit or not, or what you might just need to alter to install the systems.
Great. Lisa Marshall said National Grid will be holding a public meeting on their latest report on how they plan to meet long-term energy needs in their downstate territory without the Williams pipeline. They are continuing to say they need the Iroquois expansion, LNG in Greenpoint, Brooklyn, and the largest CNG trucking operation of its kind in the US out on Long Island. They are predicting even greater gas demand for the future than they were in 2020. It's all pretty horrifying. It would be great to have folks from MA join in. So Carl said in the mid 1990s, there were several similar projects in commercial buildings monitored and documented by Mass Electric. Have you reviewed that data and evaluated how these geos have fared over the past 25 years?
Yeah, so Carl, I specifically, it's not coming to mind right now, but I do know that, you know, we probably have looked, we've tried to do kind of a backlog of what's been installed, and if there were any similarities to take that data and try to use it to kind of guide our thinking on it. The buildings you're referencing don't come to mind off the top though, but that just might be my lack of historical knowledge.
Our initial feasibility study did include them. We got Mass Clean Energy Center was very generous in sharing a lot of data for Massachusetts on all the historic installs, their success, their cost, etc. I don't know if we have all the data you might be implying, but yes, we tried.
Yeah, that I know we pulled also data from Mass EC. So if they're embedded in that, then like Zainab said, likely they're in there.
Amber said that they're trying to introduce similar legislation to the Future of Heat bill in New York, but they're running into technical issues like the 100-foot rule. Would they be able to contact you to discuss any legislative ideas?
Yes.
Wonderful. Well, those are all
I'd
the
say yes
questions
too, if that's, I don't know if that was for me at all, but I'm just kind of curious in how all the legislation is going in New York. So I'd be kind of curious, but that may not have been for
honestly,
me.
that could be a town hall all unto its own, because
Yeah.
again, the success that they're having in New York is something that, much like this presentation, we could use to spread like wildfire across our industry. So that may be a great town hall topic, is the success in New York and the legislative issues that they've been able to overcome. So anyway, those were all the questions we have right now. If any more come in, we'll be happy to email those along and then send the answers. But again, I couldn't be more thankful for both of you in your presentation. I think it's just incredibly encouraging. And again, as I said, this will be up on YouTube, and I would encourage everyone on this call to share this with whomever you think might listen, because I think it's just it's a huge opportunity. And Zainab, as you said, the skies are kind of limitless. I mean, there is so much opportunity here to utilize the system for energy efficiency and to tap into resources that maybe haven't even been thought of yet. So I think it's just wonderful. So we'll end on that. I would remind everyone that our conference information is up on our website at igspa.org. And then we will be sending out the announcement for the August town hall. We are going to have a couple of residential installation contractors talk about their success stories and how do they find success selling geothermal, whether it's through third-party financing, or how do they get their foot not just in the door, but close that sale as well. So we hope to see everyone in August, but thank you again for your time today, and we will talk soon. Thanks, everyone.
Thank you.
Great. Thank you. Bye-bye.
Thank you.